Yeah. Now that we have run our hydro model with dye concentration, let's go ahead and view our model results. So in order to view the model results, today we'll be just looking at 2D, and probably we'll look at more 3D tomorrow. Click on the view plan here. So if you click on drop down, you should look on view model results. If you just click on this button, it will automatically show you the results. Okay, so now let's go ahead and look at our dye concentration at some random points and see if it's changing with time or not. So in order to plot the dye concentration, go to your viewing option, water by layer, and under the options click on other, and then it will select your dye. So on the top there is a button next to this yellow plus sign, that is distance tool. Click on that button and it will pop up this small window which says cell selection list. Now let's click on the rev 1, rev 2, rev 3 to see what's going on here. Here, this button right here. Yeah, it doesn't have to be exact points, you just click on some random points. We just want to make sure the dye concentration is changing with time. And I selected 3, so it shows here I, J and K of those particular cells. It doesn't have to be the same for all of us. Click on show. So when you click show, it will ask you the start and end time, but by default it will choose your start run time and end run time. I'll just click OK. Then it will go ahead and process all of these for us, and it will give this dye concentration time series. So these are dye concentration time series at 3 different locations. So you can see initially there is where is those locations. So the rev 1 is just upstream of East Branch and wastewater treatment plant, so it will have the lower concentration at first. And rev 2, it will have a direct impact from wastewater treatment plant because it's going downstream, so it will have a higher concentration on rev 2. So here the blue is the rev 1, that's upstream of the wastewater treatment plant, and these 2 locations will reach steady state after running for several days. So as a result, when you look at those graphs, where did it go? So they will eventually reach to this steady state of 1.75 mg per liter. So that's what happening in our system. Now let's go ahead and import time series into our model. First, let's plot this profile. So if we want to see the distribution of dye concentration throughout this river channel, we want to use this longitudinal profile feature. Click on this button that says longitudinal profiles. So after you click that, it will give you several options. So if the first option is, it is asking us how do you want to plot the longitudinal profile. So the drape line is a poly line that goes through all the grid cells into our domain. So if you want only these few cells, you can have a polyline to connect these points, and then you can create a drape line from that and specify it over here. But we are interested on the whole domain, so let's go ahead and use I of 3 because I is not changing. That means it will extract everything from this location downstream to upstream. And layers here means you can have up to 10 layers, but if you're not sure what are the values you want to enter, if you hover over that text box, it says press F4 for options. Click on F4 and it will give you options that you can choose. The first option is you can have 1 to KC, means KC here is the maximum number of layers in a model. Since we have only 1 layer, it will be 1. And if you want to plot depth average, it would be 0. And if you want to have water surface elevation, water depth, it would have a different number. we are interested in die concentration, and we are interested in layer 1 for now. So just click enter the value 1 and click on show. So it will give us the die concentration at that rebirth channel at time 200. That's our initial condition. We had 0. That's working just fine, right? So if you look at on the top, there is this button where you can scroll this wheel, and you can see how the die concentration is changing in each time step. So if you keep moving, it will reach a steady state, and at 1.75 it will be a straight line, then it will be a sudden drop. So what's happening here, this is our upstream, and 0.2 concentration is coming from upstream, so that's a straight line. But at this point here, we have the wastewater treatment plant coming into play. So this higher concentration here is because of the wastewater treatment plant. So you see a straight line because of upstream, and then it reaches a steady state. All of a sudden the die concentration goes up. So now we have the data to compare from the analytical solution. Let's go ahead and import that data into this window. In order to do that, so if you look on the top, there are a few buttons: I, import, export, and this animation. We'll probably have to play with this animation tomorrow. Let's go ahead and click on I, import series from a file. Click I, and then locate to the folder. Let's see, where's my folder? Go to the same, not that, projects, 1D Reaper, data. I think it's so where it says die CXT 218, let's go ahead and import that and click open. So it's asking if that file is a time series, if the x-axis is time, but this is not time, so we're going to say no. I'll show you the format here just a second. Data. So this is the file we are importing. So it has just 3 points. At 3 different locations we have the die concentration that was calculated and formatted in the way that we can use into EFDC Explorer. I'll talk more about formats of the file, what each format mean later, because we haven't even finished one model yet. So let's go back. Are the x values dates? Click no, and then it will say you to enter the series into the series number. So by default, if there is only one series on your window, that's 1. That's the series 1. Then you can have any number greater than 1, right? Its default is 11. Should be 2. That might be a bug, I think. You can leave it like 11 and just click OK. Click OK. Then it will plot another new line into our window. However, it's plotted as a line, but this is data at different points. Since this is not a continuous line, we want to change the format of this added line. Let's go ahead and do that. Right click on legend. If you right click on legend, it has, not sure why I have 4. How many you have? So we're going to use only the first and the last. You could just, these are deactivated by default, so we don't need to worry about it. So let's go ahead and check the last button, last time series, and we want to change the series as a symbol. So let's go and click next to the symbol. It's selected none right now. Click on the drop down and use square field or whatever you want. I just want something to be distinct, and let's change the line formatting to no line, we don't want any line. If you're happy with the color that's being selected, I'll just choose red. I usually choose red for the observed or measured data. Now click OK. Now you can see our observed or simulated or analytical solution matches with our model results. So this is how you import external time series into your model, so you don't have to export it to some third-party software and then do your reporting. So now you are happy with this plot. I mean, you could do some modifications, make your labels bigger or whatever, but now let's go ahead and save our image to our file. In order to save this image, go to EMF on the top, that says EMF. It will export to the Windows Meta file format, EMF, and by default it will give us a name depending on at what time step we are comparing the result to. I will just use default for now. Click OK. So now we have compared dye concentration profile. Let's go ahead and create what we want to do next. Let's run another quick model and assign the decay rate to our model and see how our model behaves. Okay. Go to save. You want to save this model to a different directory because we want to have each model and results for each model so that we can be able to come back and see what was the result for each run. In order to go to a previous directory, double click on the main folder and click new. I will say hydro dye decay. Click OK. Click OK. So now it will be saved to a different directory. Let's make a comment. It's usually at the top. The new one should go at the top, because if you have so many runs, you have to scroll all the way down. Let's go and cut this previous model information and paste it above the run one. And this model information is hydro dye decay based on hydro dye. So you don't have to write all the parameters in the model, just write what is being changed from that previous base model. So dye decay rate equals 0.15. Okay. So that's the only thing we're going to change in this model. So in order to do that, let's go to this tab which says the dye/age and go to this dye decay growth rate and change to 0.15. So this is the only thing you need to do. So this decay rate will be automatically included into the transport equation that's being solved by UFDC Plus. And let's save our model. So in order to reflect any changes, you always have to save before running, otherwise it will just use the previous saved state. Let's go ahead and run again. Just use 4 and be optimistic that it runs faster. Next thing I need to do is go into calibration forms and show the calibration for 3 stations. I have pulled the model that I have already run since everyone has run. Let's go ahead and view the results again. Go to your view plan. Go to viewing options and go to water by layer. Again, we're going to do the same thing. Just want to look at the steady state dye concentration for the river. Go to your longitudinal profiles. Again, it's the same option as before. We'll use I of 3 and line 1 value 1 and show. So here it's the same as before. You can drag it to go to the particular point of interest. Let's go to 218 days and see what happens. I mean, there shouldn't be any change from 218 to 220 because we have data for 218. So I just want to go to 218 and compare to the analytical solution. So if you want to go to particular date, you can also use the keyboard's shortcut Control G as in girl, Control G, and you can go to, you can write the values. I think it's pretty handy, and it works on the view plan and time series both. Okay. Click OK. So it's time 218. Now let's go ahead and import our measured data and see if it matches with the model results or not. Go to 1010 distribution project on the river data 1D river analytical solution is the file that you want to choose. Okay, click open. Are these x values dates? No. Then it will give us 11. Click OK. Now our analytical solution and our model solution are right on top of one another. So yeah, I mean, if you want to improve it further, you could decrease your resolution in y direction, but I think I'll call it good if it matches this close. The analytical solution, again, you can change the color. I'll just change to square field, change to red color, thickness no line. Click OK. So your solution should look something like this. So this is a good test of EFDC software itself. It's how good it's matching to the analytical solution. So if you're happy with how it looks, let's go ahead and save it. I'll just save the name. I'll just use the default name. Click OK. So one important thing here is you could save the settings of this file. You could save the settings of this plot. So if you want to make another new plot and you want to have the same exact symbols, same exact line color, same x and y axis, you can save the settings here. There is a save button next to EMF button, and click on save. Then it will allow you to save design plot setting files. That's the extension DSG. So what I did was went here, save settings next to this EMF, and you can write dye profile settings. So it could be you can have salinity, dye, versus elevation. So every time you can just import these settings by clicking on read settings and then use that file to make consistent graphs. Okay, everyone is following so far. Now let's go ahead and look at our calibration tools. Before that, I'll show you some options that you can choose to view your work surface profile or your time step history. So if you want to look at your time step history, you just click here, go to modal analysis tab and go to miscellaneous. Click on time step history. It will be a straight line of 100 because we have used a constant time step. But if you had a dynamic time stepping, it will be changed with each time, and you would get a rough idea of what was your time step, overall time step. Now let's go to the modal analysis and go to modal calibration tab. We will configure time series comparison window. Click on time series comparisons and click on define edit here. So we are going to create 3 locations. So I went to model analysis, model calibration, edit. Yeah, let's go to number of time series 3. X. Here now you have to give what are the locations of the cells that you want to have the calibration to. So I'll give you X and Y so you can copy. X is 15, Y is, let me pull out the PowerPoint so it's easier for all of you. Okay, can you see it? Okay, so these are the X and Y values that we want to use in our model. Let's go ahead and copy that. So the first X means X coordinate, Y is Y coordinate, K is the layer, ID is the what is the station name that you want to give. We already had 3 stations, Rev 1, Rev 2 and Rev 3. Let's write I, X and Y first, and then I'll zoom to the rest of the areas. So on the depth, if you want to extract the depth at particular layer, then you would specify a depth. For this case, we are just using a layer value, and even if you choose depth, it will still be the same because we haven't any layer or any stratification in this case. So now in order to specify the path name, click on the field and right click on that field, and then it will allow you to browse to that particular file. So the first, for the Rev 1, just choose the file that says die tsr ts rev01.dat, and for Rev 2 ts rev02.dat, for Rev 3 ts rev03.dat. And then so after you have specified your X and Y index, X and Y coordinates, and you have specified the path name, it's time to specify what is the parameter that we want to extract. The parameter that we want to extract is 3. If you don't know what is the parameter, just hit F2. I think let's see, F4. Control. Right mouse click. Oh, it's a right mouse click. So it's not consistent, but so if you hover on that particular field, it says right mouse click on the column row for options. Right mouse click and it will give you all the options that are available. So we are interested in die, which is the number 3. Let's go ahead and enter 3 on all of the fields. And filtering. So if you are going to use a filter in your model, like every few, you could have low pass filter or high pass filter as well. You can hover over these fields, filter. So in order to do a filter, you can right click and it will give you different options. So if you are using, if you have a value greater than 0, it will use a number of hours to run the running average filter. But if it's less than 0, it will use a low pass filter, and it's very useful in the postal. Right. So if it's greater than 0, that's moving average, but if it's less than 0, then it will be a low pass filter. And then group, you each group means if you want to plot all of those plots in separate, you want to have different groups. But if you want to plot all of them into the same plot, you can have group 1 for all of these, and all of them will be plotted on the same graph. And the last, use. Even if you populate these values into this calibration form, but if you don't want to use or display some of those, you can use 0. And for some reason, if your x and y coordinates are out of bounds, that it doesn't fall into your model domain, it will automatically go to minus, it will E of TC will automatically assign -1 to those values. So you might want to correct those if that's the case. So for this case, just enter the value of 1 for use. Now I'm going to use PowerPoint because I did not enter those values. So all of you have entered this. Now let's go ahead and click OK. One more thing here. So here, time tolerance, you have to change this time tolerance to 15 minutes, or you can change to 30 minutes depending on the frequency, because you have the frequency is 15 minutes for now. So let's go ahead and change it to 15 minutes. However, if you had a higher frequency, you would have to change the time tolerance. So the EE would try to find the values within that range and then attach to the measured data. Now let's go ahead and click OK. I'll just cancel. So after you have click OK, now click on plots. So if you want to view the plots, you can you don't have to select anything and click on OK. Then it will automatically show you the plots. Click OK. Right now I don't have anything, so it's not showing anything on my screen, but go to plot. Let me quickly enter those. Now let's go ahead and click plots and click OK. So it will automatically go ahead and plot these here. The reason it's all plotted on the same graph is I chose group 1 on all of these. I'll go ahead and change this group to 1, 2, 3, so it will show on each separate plots. OK. So now you have Rev1 at first, and if you want to change how it looks, I want to change the layout. I don't want the symbols for the model results. Right click and go to Rev1, and then I'll change the symbol to none. Model results, I want to make it blue color. Observed, I want to have red dots. That's fine. So your model results should look like this for Rev1. Now if you want to, let's change this y-axis as well, so it doesn't change with every plot. Right click on the axis where it says where it has the axis labels, and go to bounds. So by default it will be selected automatic scaling, but I want to change from 0 to 2 because maximum concentration is up to 1.75 as we saw it before. Measure, you can change to 0.4 or whatever you want. Minor, I'll just keep auto. So after you change that value, it will ask you apply for all calibration time series for the same parameter. We want to say yes, because all of our plots will have the same axis now. You'll notice that it's way too low because it's a 0.2 concentration that's coming from upstream. Now let's go to our second plot. In order to go to second plot, you can go click on the blue button on the top. Or just hit paste down key. It will take you to the next plot. You can fix the font color for this as well, which I'm not going to do now. Then for the last plot, you go to that same button, and then it will show you the dye concentration for for that location. Paste down key. this you probably use
page
that
down.
page
Yeah,
down.
arrow.
Yeah, yeah. So remember, page down and arrow keys are confusing at times. So now that we are satisfied with how our plots look like, let's go ahead and close this window. In order to close, there is a red button on the top right that says minus or something. So it says it will stop processing our output files. Now click on plots again, and now click on automatically generate time series plots, and click on second option as well and click OK. So what it does now is it will automatically process those plots and save into our directory. It will create a subdirectory. Let's go ahead and look at our folder structure now. I think it's a good time to look at our folder structure. So if you don't know where you saved your model, the easiest way to find out is you go to the main form here and right click on the yellow box, and then it will automatically copy the project path to the clipboard. So you can copy and you can just go to your Windows bar and paste that, then it will take you to the appropriate folder. So here you'll notice there are several subfolders within our project folder. So the first folder is analysis folder. Whatever you save by default, all the time series plots that we saved from ad hoc analysis will go under this analysis folder by default, unless you change to store in some other folder. Calib_export is a directory where it saves all the files for those calibration plots. So if you look into these, you will notice there are series for model first, and then if you scroll down, there will be data for the observed data as well. Yeah, data here you have these points, and model you have this many points. Now if you had any animations from your model, there would be another folder with a hash at the front, and that would say animations. So the calibration plots that we exported before, we can view it from here. I have installed Irfan View, a free software that allows you to view these EMF files. By default, it will try to open on Paint, so you cannot scroll through the plots. I think you could install this Irfan View. Let me, yeah. Windows used to have the default picture manager or something, yeah. But on Windows 10 it does not have it now. IRFAN View. It's a pretty nice software that allows you to open those files. So now you can scroll back and forth and see your calibration plots. Now if you want to calculate the statistics, let's go to the report button, click on report, and it will give us several options. What are the statistical parameters that you want to export? Yeah, and if you want to export everything, just check everything. And if you want to generate a text file that has information, just go ahead and click automatically generate reports. Click OK. Now it went and did its thing, and at the end it says the model calibration statistics have been written to the following. So this is the folder you want to check now. Let's go to our folder, run to calib_stats is the new folder that's created now. So it has all of these files. One is absolute error, absolute average error, NAT Sutcliffe efficiency. If you double click on one of the files, the format would look like this. At the top it would give you what is being done. So right now I didn't have any title, so the title is empty on mine. You could write a title. So here the statistics is given in the format each station has one row, and what is the parameter that the statistics is derived from, what was the layer that was used, what were the starting and ending dates, and what were the number of points that were used in order to extract the statistics, and what was the absolute error. And at the bottom it would give you all the composite absolute error based on all of these. So this is the overall. So if you just want one number, so this is the number you want to report. But if you want to report error by stations, then you might have to look at these absolute errors. You can copy and paste to Excel or whatever format you want if you want to combine different errors into the same table. So this is how you create a calibration plot, you create a calibration data, calibration statistics. Yeah. Yeah, this alone would save you so much time. Yeah. Every model you have output your time series. Even then if you create your own scripts and stuff, it still takes a while to do that the first time. So yeah. I mean, even if you have a scripts, unless you do your scripts for that model. Yeah, unless you write it right from the EFDC plus executable, you have to come here manually extract all the time series. So I think time series forms alone would make worth using EFDC Explorer. And there are several calibration correlation plots is similar. So the only difference here is I mean it looks pretty similar. The only difference here, I can't even tell what's the difference. So if you have to 3, you just have x and y coordinates for those cells, and specify k, depth if you want to specify depth, name of your location, the path name would still be the same because it will be the time and points, and parameter would be 3, group 1, 2, and then it will create a correlation plots. And in correlation plots there is this part different. So what are the error parameters that you want to display in the plot? If you want all of these, you can plot everything on the correlation plot. I think it would be really informative. So it's saying something went wrong because I didn't enter anything. I just ignore it. So by default, what it does, if it's something wrong, it flags -1, means it's not being used. So just hit cancel. So vertical profiles, I think we can go over these later. High frequency time series, because I have not run high frequency on this model. I remember I used the old executable or old model where I haven't specified high frequency. But if you have, I think most of you have specified high frequency dates. If you have specified, you would be able to access the form. Maybe you have not specified during this run. Yeah, maybe not. Go to timing and linkage. EFDC Explorer linkage. I mean, you have, right? Not sure. Might be. Okay. I think let's call it today and continue it tomorrow. Some of the things we'll use it again tomorrow, so you'll be more familiar.